Hey guys, this is Mr. Champlin. Today we're going to be talking about forces and we're going to be talking about force diagrams. So first of all, what is a force? A force is a push or a pull. All right, so that's a very simple, easy definition. So some examples of forces might be the weight of an object, the tension on a rope, somebody punches you in the face, that's certainly a force. The force of friction, right, when two objects are touching. Other forces that you might not think of, the attraction between an electron and a proton. Now the unit for a force is the Newton, and we've already kind of used this a bit because we did things a little bit out of order this year due to the craziness of what's going on. But you should know that forces are measured in newtons. That is the unit. Now technically, a newton is 1 kilogram times 1 meter per second squared. But you can see it's just simply easier to say 1 newton. So that's where they've gone with it. Now, if an object is accelerating, that tells you that a force is acting on it. So now, to just remind you, we've already talked about acceleration earlier in the year. And how do we know that an object is accelerating? Well, it's either changing speed, speeding up or slowing down, or it's changing the direction that it's moving in. So if it's doing either of these two things, we know that a force is acting on it, because nothing can accelerate without a force acting on it. The fundamental forces of nature. So there's lots of forces out there that are really important for physicists that you might not be thinking about a whole lot. So we can actually put these into two categories. One of these categories is called field forces. Now, field forces are forces that can act over a long distance, right? So the objects do not have to be touching. So some examples of field forces. Well, gravity is certainly a field force. So think about the sun and the earth, right? The sun is actually about 93 million miles away, but yet the sun pulls on the earth and also the earth pulls on the sun through this attraction that we call gravity. So even though they're very far away, this force still exists. So we're going to talk about gravity more in detail in this particular unit, but you should know, of course, that gravity is an attraction between any two bodies with mass. So anything that has mass is going to have gravity. Another force that we probably don't think about too often, but is super important in nature, is the electromagnetic force. We've already kind of talked about this a bit earlier in the year. And this is the force that occurs between any two bodies that are charged. So in other words, we talked about positive and negative charges, right? And of course, this force can be attractive or it can be a repulsive force. If the charges are opposite, they will attract. If the charges are the same, they will repulse. And another force that you probably are not too familiar with is the strong nuclear force. And this is the force that holds together quarks. And quarks are very, very tiny particles that actually make up protons and neutrons. So they hold them together. So basically, the inside in the nucleus of the atom, all of these particles are kind of, so again, some of these forces, just to we have gravity between the Earth and the Moon, let's say. So this is an attractive force. Again, happens over a long distance. The Earth's magnetic field is an electromagnetic force that actually helps to shield the Earth from a lot of the radiation from the sun. It acts as kind of like a force field, so to speak, that prevents a lot of the destructive radiation and particles that the sun spews out from actually hitting us. And then, of course, we already mentioned the strong force, which is what helps to hold the particles in the nucleus together. So these are all forces that act over a distance. Then, of course, we have contact forces, which we're more familiar with because these are the sort of the everyday forces that we often encounter. So a contact force is any force that operates when objects are touching, as the name suggests. So some examples of that would be applied forces. So in other words, if you push something, that's an applied force. Friction, when two things, of course, are rubbing together. Tension forces is what they call it, when things are held together by chains or ropes or something like that. And the normal force is, and we'll talk about this more in detail, but the normal force is the force that acts opposite to gravity. So for example, this guy is standing here, gravity's pulling him down, but he's not falling down. Why not? Well, because the ground exerts an equal but opposite force going up. And so that equal but opposite force is what we call the normal force. Okay, so you're going to do an activity where you're going to be labeling free body diagrams. So in a free body diagram, we represent an object, often with just a simple box. This could be a car, a person, whatever, it doesn't matter. And then we draw the arrows going out from the box and the forces that are acting on that box. And so the arrows obviously indicate the direction that they're going in. So remember, forces are vector quantities because acceleration is a vector quantity, and acceleration is a vector quantity because velocity is a vector quantity. And so just to give you some examples, here we have an object. We have the force of gravity acting on it, so that force is pulling down. We have the normal force, which of course is going the opposite way. We have an applied force, it's being pushed this way, but then we have a force that is going the opposite way, which is the force of friction. Now, of course, these forces could be the same magnitude and they could cancel each other out, or they could not be the same magnitude, or they could be not equal, and this could cause them to accelerate in a particular way. Now, again, I want to give you a list of sort of the common forces that we typically see in these free body diagrams. So we mentioned gravity already, always pulling down. We mentioned friction. You can actually have friction on both sides of the object. You can have friction this way and friction this way. The normal force, which always acts opposite to gravity. Tension forces. Again, this is when there's any kind of ropes or chains involved. And air resistance. Air resistance is actually a type of friction, right? When you're moving through the air air resistance kind of slows you down. And applied force is kind of this just whatever we call when you push or you pull something. So it's kind of a catch-all name.